Can you tell us about that phone call and how you connected the dots from what you heard to where you went?
Remember, at the core, the company was pioneering a new way of doing computing. Computer graphics was the first application. But we always knew that there would be other applications. And so image processing came, particle physics came, fluids came, so on and so forth. All kinds of interesting things that we wanted to do. We made the processor more programmable so that we could express more algorithms, if you will. And then one day we invented programmable shaders, which made all forms of imaging and computer graphics programmable. That was a great breakthrough, so we invented that. On top of that, we invented, we tried to look for ways to express more sophisticated algorithms that could be computed on our processor, which is very different than a CPU. And so we created this thing called CG. And so I think it was 2003 or so. C for GPUs. It predated CUDA by about 3 years. The same person who wrote the textbook that saved the company, Mark Kilgard, wrote that textbook. And so CG was super cool. We wrote textbooks about it. We started teaching people how to use it. We developed tools and such. And then several researchers discovered it. Many of the researchers here, students here at Stanford, was using it. Many of the engineers that then became engineers at NVIDIA were playing with it. A couple of doctors at Mass General picked it up and used it for CT reconstruction. So I flew out and saw them and said, what are you guys doing with this thing? And they told me about that. And then a computational, a quantum chemist used it to express his algorithms. And so I realized that there's some evidence that people might want to use this. And it gave us incrementally more confidence that we ought to go do this, that this field, this form of computing could solve problems that normal computers really can't, and reinforced our belief and kept us going.